Today, I want to talk about, briefly, this notion of discovering the data lakehouse. Don't want to take up too much because I want to let everybody get to the actual breakout session hands-on as well. So, let's dive in a little bit. First, I just want to start of like how we view the world at Databricks, right? Databricks is a company's now been around for almost 9 years, has basically thousands of customers. So some lessons we've learned along the way. It's informed what we build the product and where we see things going next. So, first off, I think one of the key things that we've seen now is this notion of data creating winners. Whether you call them the digital natives, the born digitals of the world, and then the fast forward, forward-leaning enterprises, you can just see those who are leveraging, data and AI are growing their business at a tremendous, tremendous clip. So the problem is, though, that, I would say 9 years ago, people were like, well, how important will data and AI be? But now we've seen, okay, that is critical. The hard part is how do we do it? And there's tons of different statistics from everywhere, from the Forbes and the Gartners and the Forresters, that just say either I'm not using all of my data, or it's challenging, or it's hard to get it in production and live up to all of its potential as well. So let's dive in, first looking at what are some of the things that those who've been highly successful do that other organizations are trying to emulate. So what we talk about is, when we work with these various leaders, there's kind of 4 core principles that they believe in. 1, that ML and AI are the future. 2, to use open source and open formats. 3 is this notion of planning for multi-cloud. And then finally, 4 is, leveraging a simple data architecture. So let's jump into each of those, discuss what that actually means, because those are a bit high level. So first of all, this notion of fully embracing ML and AI. So if you look at it, organizations have been doing this context of descriptive analytics for a while now, right? Since, data warehouses have been around for decades, and you just want to understand, run some reports, figure out, what happened, for more or less. But now, as we think about this maturity curve, people want to move beyond it and say, well, why did it actually happen, right? Okay, I got it. Sales went up or it went down, but why did it happen? Now I want to understand what is going to happen in the future. And the pinnacle is like, how can I influence it and make it happen, right? And as you move towards this is clearly in the domain of advanced analytics, machine learning, and AI. And there's numerous studies around just showing that this is the core part. So when you now talk to, a lot of different leaders, whereas many years ago, somebody would say, hey, look, like I'm just focused on my descriptive analytics. All of that stuff is way out in the future. Now organizations are saying, no, I need to bring, data and AI together. Those who are ahead in the industry are already leveraging it, and everybody else is basically trying to get there. So why do I bring this up, the data and AI maturity curve, is because as you're thinking about a platform as an organization, we talk with some folks who are just trying to lift and shift and just say, hey, look, how do I take my existing data state, take it to the cloud or modernize that, and I'll focus on data science and machine learning later. It's really, really hard to do so. It's incredibly hard to add it. So you end up re-platforming. So part of this is, how do you think about the future? How do you build with the optionality to get there? And so a core part in how you do that is actually leveraging open source and open formats. Now, this doesn't actually mean what it used to mean a little while ago. So especially in the on-premise world, when people talked about open source, it usually meant, hey, I want open source piece of software and sell me services and support around it. That's all I care about. I don't think that makes as much sense in the cloud, because mainly in the cloud, most people are consuming managed services. And a lot of people think that the option is, okay, do I pick something that's open source or do I pick something that works? Clearly, you always pick something that works. But usually when we talk with organizations, what they talk about for open source and open formats is something a little bit different. It's this notion that they want to know, all right, anything that I invest in, the pace of innovation is so fast, right? For example, on ML and AI, I'm willing to tell you that many of the technologies we'll be using 5 years from now nobody's using today. They're in a research lab or they're a small startup or somewhere else there. So innovation is happening so rapidly, you want to be able to embrace it and give yourself the optionality. So one, they want to know when they think about open source and open formats, what is the cost of portability, right? So if I ever want to move off of this and embrace other things, how difficult is it? It's not about just some code in a GitHub repo somewhere. Two, what is the breadth of the ecosystem? No one tool will be the end all be all. So how do I leverage all of them and come together to build an end-to-end platform? And three, how difficult is it for my end users to look at? So this is one of the core parts that we see organizations leveraging, saying, I would like that optionality to get value, but be able to evolve as innovation is coming without replatforming. So this third principle is this notion of planning for multi-cloud. I used to joke that, and I have plenty of bad jokes, so I apologize ahead of time, but that there's three types of organizations: those who are multi-cloud today, those are who are aggressively moving towards becoming multi-cloud, and those are who are in one of the first two categories but just don't know it yet. It's for a variety of reasons, whether it's for economic leverage, for geographic reasons, or as organizations go, they are acquiring basically kind of different entities and stuff like that. It will happen. You will be striped across multiple clouds. Now, that doesn't necessarily mean we have these scenarios where for one workload or one query, I am basically moving across 50 different clouds. But it does mean that you have end users going across all of them. So it becomes important to think about, how do I get a consistent user interface? How do I move workloads between them? How do I basically govern them and think about things like disaster recovery and backup and consumability of data? So that becomes a key piece. And then the last one is this notion of having a simple data architecture, right? So, I would say back in the earlier days, what would end up happening is that folks would look at like stovepipes. Okay, I have a single use case. I'm going to go solve it for this use case, and this use case, and this use case. And now folks are seeing that, look, we would really like a core data platform to power these use cases. And so what you want when people talk about a core data platform is oftentimes comes around this, the substrate of the data governance, right? Data management. So how do I think about understanding my data? How do I think about securing my data? How do I think about making it accessible and consumable by a wide variety of folks, right? So that's the key part as they're looking to to rationalize their architecture. So why do many folks struggle to get this right? We walk into a lot of different organizations and their world looks like something like the following, right? So great, you've got your cloud data lake, and that's where most data starts. Over 90% of the world's data sits inside of data lake. But then you start looking at it because you have these other systems. How am I going to move data into them? How am I going to basically decide on all the purpose-built systems? Now, how do I layer on various kind of capabilities and what the end users need, and they're blocked from working together? This hodgepodge is oftentimes one of the big challenges. It's what drives some of those things I mentioned early on that said, how do we get to that world of basically driving all those benefits? Why are we falling short? Now, clearly you look at this picture and you're like, this is exaggerated. This looks like a mess. But I will tell you, this is where many organizations are. So the next question then becomes, well, how did they actually end up here? Why did they end up here, right? And so in order to do that, let's go back and look at the following. There have historically, from a data management perspective, now been, two sides of the world, right? Data warehouses have been there for decades. And so, they did a lot of things great, or a lot of things really well, which was that they were easy to use. They basically had highly, reliable, high integrity data, and they were very performant for SQL, right? But then they had, some issues there. And so the issues were, frankly, one, what if you wanted to do something more than SQL, right? As I mentioned, advanced analytics, people wanted to do all of those other capabilities. And frankly, take it for a person who did a bunch of research, it's pretty much damn near impossible to do true machine learning in kind of relational systems. So you end up pulling that data out elsewhere. Second, those systems make it much easier to get data in than to get data out, and they can't, have all of your data. So then we started saying, okay, we're going to have this wonderful world of water analogies, data lakes, data streams, data reservoirs, and the like, and they were going to be open, and you're going to land all of your data in fantastic economics. Yeah, that was great, but they didn't solve some of the other issues that we had, such as how do you actually make the data reliable? How do you make it performant and easy to use for SQL? So now they started serving different purposes. And so you see a lot of these organizations try to rectify this dichotomy that, data lakes are open, data warehouses are proprietary, right? Data lakes are mostly Python focused in R, and, basically warehouses are more around SQL. Data lakes think about things as files. We talk about object stores, right? We talk about, S3 and ADLS and GCS and files. Data warehouses talk about tables as a logical construct and adding schema. So where we started looking at this was saying, well, why can't we have the Goldilocks solution, right? Why can't you bring these two together? Can you take the best of each of the worlds? So from a data lake perspective, can you take the fact that it's open format for all of your data that's easy to access by kind of a wide variety of tools and supports machine learning and AI natively from inside of it? And from data warehouse, borrow many of those capabilities that they've built around data management, data governance, and high performant SQL workloads. And so what came out of it was this concept of, a lake house. Some people love the term, some people hate it. My favorite quote is a customer asked me when we introduced it, is it where my data goes to relax? And I wasn't really quite sure how to answer that question. But at this point, you've started to see lake house as a concept take off since we started talking about it. You see, Amazon talk about it, Google talks about it, Microsoft talks about it. Gartner talks about it. It's, people are looking at it as this is the model that you want to go towards. And so what it ends up looking like in actuality is something like the following, right? You want to say, okay, one, it's built as a lake first model. As I mentioned, over 90% of the world's data sits in a data lake. Why pay extra cost and complexity to move it elsewhere? And it works across multiple clouds, right? So it deeply integrates and operates there. So the end user gets the benefits of each of the clouds, but without being exposed to the complexity of it. And then it talks about how does it have, the various things that you need around kind of data processing and management from, open source and open standards, and all of that data governance. And then frankly, make sure that these different types of workloads, everything from data engineering to BI, and SQL analytics, data science, ML in real time, are all kind of first-class citizens, in this. And so this notion has started to take off. And look, when you talk with folks, nobody says, well, this is stupid. Why would I ever want to do this? The notion is, yeah, clearly this makes sense. It sounds great, but it's too good to be true. There's no way anybody could pull this stuff off. Like there's a reason that we're going to lose something along the way. So let's talk a little bit more detail from a Databricks perspective of how we went about actually making this, a reality that now, many of our customers are adopting and leveraging. So the key part is we start with that, chart that I said, okay, what are, the key challenges? So we said, okay, look, I want to start from a cloud data lake, but then what were some of those big challenges? Which said, well, can you actually support SQL? What about like some traditional data warehousing workloads? What about security for the data? What about performance? What about reliability and quality, right? And so out of that came this, innovation, fully open source in the Linux Foundation called Delta Lake, right? And so Delta Lake says, okay, as a result, with one interface, I'm going to natively support, both Python and SQL and other languages as well, right? Second, it's going to look at it and say, it in one world supports those different types of workloads. Are you doing analytics or machine learning? Are you streaming or batch? It's all kind of one interface brought together. It provides this notion of having fine-grained role-based access controls. It looks at a lot of those capabilities, frankly, taken from data warehouses of how do we do everything from simple statistics to more complex things like Hilbert curves and Bloom filters to give you advanced indexing, caching, automatic tuning in the background, and then gives you the notion of transactions, right? You can have transactions, make sure data gets in there reliably, being able to rewind and look at, kind of what were previous versions of the data. So now it's taken this first step and said, okay, we have laid this foundation. So your data, again, in the data lake, you don't have to move it. Delta Lake is open source, and it's just basically this metadata piece that gives you these capabilities on top. And by the way, it is basically the open nature of it means that you could use a wide variety of tools, both to write into it and to read from it without ever even needing to go through something like a Databricks if you didn't want. So let's talk about now how we build out a couple of the other parts of the layer as well. So one, okay, great. You've now said that you can help me get my data in a reliable fashion. That's fantastic. But it still doesn't help me. How do I think about making the data consumable? And so that's where we start talking about the notion of catalog. And look, catalogs have been around for a while. That's not something new. But I think that there's a couple of important things from a catalog. One, it shouldn't just be on data sets. You have a wide variety of assets, and it can't just be data that's sitting in one place. Even as folks move to a data lake, that there's going to be other data that sits out in whether it's another data warehouse, or it sits in basically operational data stores or a graph database or the like. So how do you make those work together? The next one is I have different assets. Like I have, basically feature pipelines, and I have machine learning models, and I have notebooks and dashboards and all that. Why? These are all my assets, secure assets. And then also I need to make sure that you work across, multiple clouds in that context. And I need you to basically be able to plug, if I have other systems that I'm using, plug in well, right? So if I'm, needing to use something like a Glue on one side or a Purview on the other side, or an Elation, or Calibra, like how do you play well with those? So that's important. So what Unity Catalog basically gives is all of those capabilities. You could see the set of assets that it's designed to secure. And then there's other pieces in there that are important, right? So what about lineage? This is a huge part as folks look at it, is to say, okay, I can now track all of the modifications and changes and see, frankly, the DAG. And so if changes are being made upstream, I can push properly downstream all the things that are happening. I can move to more attribute-based access control of saying, okay, I have a policy. This data is basically, this table is tagged as PII. This person does not have access to PII data. Properly allow me to basically specify access control in that way. And then looking at how do you use, various tags and classification and auditing. And then this notion of how do you actually go about and share it. So from a sharing perspective, as you look at this, it then says, again, in the spirit of being open, the concept of delta sharing, where a lot of people are looking for how do we share pieces of information. But what's usually happened, your notion of sharing data is either, use FTP and copy a bunch of buckets or give access people to random buckets, or you have to use a proprietary vendor and everybody along the chain has to use that. So what delta sharing actually says is why, Delta was open source, basically plug the sharing concept into it, where there's a sharing notion that you can go through and say, okay, I want to share all of these different aspects, and people can consume it through whatever they want. There's a wide variety of tools, both open source and proprietary. So it's a way that you get the benefits of, kind of all the auditing, central control and freshness, for example, by tying into lineage and allowing people the flexibility to use the technology that they actually want. And as I mentioned, so you could do it at a table level, and then being rolled out is also at, for example, the column, row, or partition level as well. Okay. So if we transition a little bit from more of the data management side, next is what about machine learning and data science? And those are kind of a little bit different. From a data science perspective, what people are looking for is collaborative notebooks and dashboards that allow me to do quick, interrogation of the data. And I want to be able to use whether it's Python or R, or even if I wanted to use Java or Scala, and frankly, SQL gets used often as well. How do I get native assets to it? How do I quickly, put things into projects and scale and remember them as well? And then how do I move over to machine learning? And in the machine learning world, people are talking about things like model registry and reproducibility. So ML ops, how do I build a pipeline that goes all the way from, development of the model to training it, to validation, to serving it, and then monitoring it and doing iterations beyond that. Having capabilities such as, feature stores and model registries and being able to pin those things together. Having something like Delta Lake that gives you the ability to not just pin the parameters of the model, but also the version of the data that you use, so you can get reproducibility and consistency on those types of things. And then also moving for kind of less sophisticated users, things like auto ML. But again, we use something called glass box auto ML, which says what you want to do is automate everything, but show all the details underneath for for advanced users if they want to go and understand it. And so you can see what this world looks like from a machine learning perspective, that you see, okay, you have everything of the life cycle from data prep and data versioning through kind of all of the core pieces of featurization, model tracking, and model building, to actually serving and monitoring. And then the nice point is that you can actually use whatever type of data that you want. There's a wide variety of engines that are built in, everything from, think like R and scikit-learn, to, if you want to use Spark, to basically like XGBoost and Keras and PyTorch and the like. And then you can deploy it wherever you actually want. So it gives you this flexibility of a full ML lifecycle deployment. Now, just basically a couple more slides here before wrapping up. One, what about the data engineering side of the world? And there's a couple of things there, right, for data engineers that are important. Is one, look, notebooks are great, but a lot of what I want to do is I care about CI/CD. So talk to me about being able to work from my IDEs. Talk to me about being able to use basically projects and repos and tie into my version control systems, such as a GitHub or a GitLab. Then talk to me about what do you have from a orchestration perspective, right? And as we talk about an orchestration, the answer is like, there's basic jobs that says, okay, you can give it a job, it'll run regularly, or adding more sophisticated capabilities with something called Delta Live tables, which is effectively says, why don't you declaratively tell me what you want, and I'll build out the full DAG, automatically monitor it, restart where there's failures, help you understand things about data quality and lineage as well. Or even deep tying in with things like, for folks who want to use basically things like Airflow or DBT, natively tied into the platform as well. Okay. And then lastly, we move on to this notion of SQL, right? Remember that this was always, people would say, hey, is this an Achilles heel of, the data lake and the lake house? And the short answer is, we actually went through, from a Databricks perspective, and rewrote the entire, guts of the engine as a best-in-class MPP engine. So think about using, kind of whole stage code gen, built for SIMD, basically hardware, brand new cost-based optimizer, caching layer, all of those kind of things. And so what that gives you, what you care about at the end is, phenomenal performance, not just price performance, but performance and concurrency on, your BI and SQL workloads. It has either, for your SQL users, the fact to just come in and say, I don't care about any of the rest of the things. I just want a SQL in the box, autocomplete, be able to see my tables, use it, quickly create dashboards, schedule, email reports out of it. That's how we consume most of our analytics at Databricks ourselves. Or you can basically take your tools of the Tableaus, the Power BIs, the Lookers, and plug them directly in and be able to leverage them as well. So now, if you have a platform this broad, one of the questions is, how do you not overwhelm the users? And so one of that is we have this concept called role-based experiences. So if somebody comes into a Databricks, they get to self-select which world that they are in, right? Data science and data engineers care about, the notebooks and the schedulers and kind of get the full, guts of everything that's there. Machine learning users, what they really care about is kind of much more so, this notion of, how do I look at models and my feature store, model registry, and ML ops and reproducibility and experiments. And SQL users are like, don't talk to me about other languages. It says it in the title, I'm a SQL user. I just want to see SQL in that simplified interface. So this way, in one platform, you get the ability to self-select to basically meet users where they are, but at the same time, one platform underneath all of the things of like the data, the capability, the securities, the underlying infrastructure is all shared, which helps eliminate some of those silos we talked about. And so then if we go ahead and we look at this, Databricks now has Lakehouse adoption across a wide variety of industries. You talk about some of the small up-and-comers to some of the largest enterprises in the world across a wide range of verticals. It's a good testament to the fact that this concept of Lakehouse and being able to bring these together and all these capabilities on a single platform and working well with the ecosystem is something that's delivering a lot of value to customers.